the next utility function was given to us by the combination of Cobb and Douglas. It's a mathematician economist combination, and Cobb Douglas basically came up with a utility function which looked like this: x to the power alpha into y to the power beta. Okay, can any of you tell me what kind of a real life example can you give me for a utility function which looks like this? Utility is x to the power alpha into y to the power beta. What real life example can you share with me to say that, okay, this is an example where we can apply a utility function of the Cobb Douglas type? So an example of Cobb Douglas kind of a utility function would be when I consume x and y in the same ratio in terms of expenditure. So expenditure on x and expenditure on y is always in a set ratio. That is px into x and py into y is always in a set ratio. Then I get a Cobb Douglas format. Okay, it can be holidays, domestic, holidays abroad, that I will choose to spend, say, 1 lakh on my holidays in domestic and 2 lakh on my holidays abroad. So the expenditure on holidays domestic and the expenditure on the holidays abroad is always in the ratio 1:2. Okay, that's an example. Food and clothing is also an example. I choose to spend 67% on food and 33% on my clothing. Okay, an example of Cobb Douglas. So you'll realize that Cobb Douglas is the typical all the preference satisfying utility function. So all the preference properties, right from completeness, monotonicity, strict convexity, reflexivity, and transitivity, all of them will be satisfied by the Cobb Douglas utility function. And here the utility function would give me convex indifference curves. The indifference curves would obviously look like this. Okay, and given indifference curves which are perfectly convex and a budget line which would obviously be linear, I will always be able to find out the optimal consumption bundle X and Y in this particular approach, wherein what am I doing? I'm equating slope of the budget line to be equal to the slope of the indifference curve. Now, the indifference curve slope we have already seen is my marginal rate of substitution. So I equate my marginal rate of substitution to my Px by Py, and this will give me the condition and the different combination of X and Y for which the slope of the budget line is the same as the slope of the indifference curve. Okay, so here in this case, I have an indifference map like this, and I draw a budget line, and I ensure that the optimal X and Y is in such a way that the indifference curve is tangent to the budget line, and that will ensure that I am at the highest indifference curve given a particular budget line. Okay, so if I have this example of u is equal to x to the power alpha, y to the power beta with a budget line which would look like this, what would I do? In order to solve this, I would equate my marginal rate of substitution, which is my mu(x) by mu(y), which is nothing but alpha x to the power alpha minus 1 y to the power beta divided by mu(y) is beta x to the power alpha y to the power beta minus 1. This is equal to px by py. If I simplify this, I'll simply get alpha y by beta x is equal to px by py. And you can easily see that alpha by beta is my xpx by ypy. Didn't I say that Cobb Douglas is an example where the expenditures of x and y is in a particular ratio? The ratio is as follows. So if you take a look at this, x to the power alpha, y to the power beta, whenever I have this kind of a format, it means that expenditure on x by expenditure on y will always be in the ratio of the power of x divided by the power of y. The power of x divided by the power of y. This is the ratio in which the expenditure of x to the expenditure of y will be. How to solve it? M is equal to xpx plus ypy. Now xpx is alpha by beta ypy plus ypy. So I can take y py as common, alpha by beta plus 1. So alpha plus beta by beta. So y is nothing but beta by alpha plus beta into m divided by py. Similarly, you'll notice that I have my x, which will be alpha by alpha plus beta, money income divided by px. So this is about solving my utility function with this kind of a budget line. Mux by muy I equate to px by py because I'm simply equating the slope of the indifference curve to the slope of the budget line. And I put it in the budget line to give me the value of y. And similarly, I can easily find out the value of x. If I know the value of y, I know that x is a certain format, so I can easily get that as well. Okay. You'll also notice that if I have this kind of a function, there is a very useful shortcut to keep in mind for any Cobb-Douglas. That is, the optimal x consumption is the power of x divided by summation of the two powers multiplied by the money income divided by the coefficient of x in the budget line. Y is the power of y divided by the summation of the two powers multiplied by the money income in the budget line divided by the coefficient of y in the budget line, which is here the price. This is the optimal consumption of x and y in a Cobb-Douglas format. You solve it, you'll get this. Power of x divided by the summation of the powers multiplied by the money income divided by the price.